हम तक पैसे? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
We have three cars that are moving in one dimension. We are going to look to find the average velocity. The average velocity, VAV, is equal to the change in its position divided by the change in its time. And of course, the change in position means the final position minus the initial position. And that is the key to being able to solve this problem, divided by the time. The time for each of these is equal to 0.5 seconds. We're going to use a number line, and so for this number line, here is 0, here is 5, and here is 5. They're different, though, because this is positive and this is negative. If we move to the right, we go in the positive direction. If we move to the left, we go in the negative direction. Our goal is to find the average velocity, which is a vector, and that's why we have to take into consideration the direction. All right, so let's look for each of the three different cars. The first one starts out at positive 2, so I'm going to put that down as A initial. And its final position is 6, which is A final. In looking at the velocity for A, we are going to take its final position of 6, and we are going to subtract its initial position of 2. So it's going to be 6 minus 2 divided by 0.5 seconds. We then have that this is equal to 4 divided by 0.5, which is equal to 8. And the unit is going to be, this is meters and this is seconds, so 8 meters per second. And you have to understand that this is going to be positive 8 meters per second, so that will be giving the direction as well. Looking at B, we know that B starts out in exactly the opposite. So it is going to start at 6, B initial, and B final is going to be here. So the velocity for B is going to be equal to its final position of positive 2 minus the initial position of positive 6 meters again, divided by 0.5 seconds. And we end up with exactly the same answer of 8 meters per second. But negative 2 or positive 2 subtract positive 6, and we end up with negative 4 divided by 0.5, which is negative 4 meters per second, which tells us that it is moving in the negative direction, whereas A was moving in the positive direction. Last one is C. C, I'm going to use the dark blue. And so we then have that it's starting at negative 3. So this is going to be C initial. C final is equal to positive 7. And it is obviously moving in the positive direction, which means that that's what we should be getting. VC is going to be its final position of 7, positive, minus its initial position of negative 3. And then I divide again by 0.5. Again, it's going to be meters per second. Here, because we have a negative and a negative, you end up with 10 meters over 0.5 seconds, which is equal to 20 meters per second in the positive direction.